We have a property integral a to b f of x dx is equals to integral a to b f of a plus b minus x dx. So let's prove this. Let's take RHS, which is integral a to b f of a plus b minus x whole dx. In this, I'll assume a plus b minus x as a t. So let a plus b minus x is a t and differentiate with respect to x on both the sides. So now we'll just differentiate. It is constant 0 differentiation, and it is constant 0, and minus 1 is dt by dx. So now dx is minus dt. So we have got dx value and we have got a plus b minus x value. So let's also change the limits according to t variable with respect to t. So now when x is equals to a, limit a, then t become, x is a cut, so t become b. When x is b, t become a. So let's apply now the same thing. Integral a become, lower limit become b, and upper limit become a. Integral b to a f of t and minus dt. Alright, minus integral b to a f of t dt. Alright, we have property when we change the limits, lower limit to upper limit, then we get minus out. Already there is minus here, so it become plus. So integral a to b f of t dt. Alright, so now let's again change variable. Let t is equals to x now. Differentiate with respect to t on both sides. So then t become 1 and dx by dt. So which means dt value we have got dx. So t is x and dt is dx. And lower limit, where t is a, then x is also a. Where t is b, x is also b. So limits remain same, which is equals to, this remains same like integral a to b f of x dx, which is nothing but what? LHS. So let's solve a sum. Integral 0 to pi by 2 root sin x by root sin x plus root cos x dx. So we have a property, right? Integral a to b f of x dx is also written as integral a to b f of a plus b minus x dx. So here board approach. Let's treat this as this. Integral 0 to pi by 2 square root of sine 0 plus pi by 2 minus x divided by square root of sine 0 plus pi by 2 minus x plus square root of cos 0 plus pi by 2 minus x whole dx. Okay. So now integral 0 to pi by 2, this become pi by 2 minus x. So sin 90 minus x is cos x. So square root of cos x by, this is again square root of cos x plus square root of sin x dx. This is I, this is also I, because both are equal here. So therefore some integral value, this integral value and this integral value both are same. So I plus I is equals to, left side is 0 to pi by 2 root sin x by root sin x plus root cos x dx plus integral 0 to pi by 2 root cos x by root sin x plus root cos x dx. Like integral a to b f of x dx plus integral a to b g of x dx is nothing but integral a to b f of x plus g of x whole dx. So this property I apply here. So integral 0 to pi by 2, I'll get square root of sin x. So let's take LCM at a time. So which is square root of sin x plus root of cos x. So we are left with root x here, root sin x here, and root cos x whole dx. So let's cancel this and we get integral 0 to pi by 2 1 dx, which is 1 dx is x. So x with the limits 0 to pi by 2. So the answer would be pi by 2 minus 0, which is pi by 2. Okay, but this is the value of 2i. 2i is equals to pi by 2. But we want I, which is the given integral. I is equals to pi by 4. So this is what our answer is. So now let's solve this in just 5 seconds. Any integral is in the form integral a to b f of x by f of x plus f of a plus b minus x whole dx. If any integral is in the form of this, then this answer directly would be b minus a by 2. So now this is the value, right? Integral 0 to pi by 2, it is f of x. This is also f of x. But this is f of a plus b minus x, because f of sin a 0 plus pi by 2 minus x nothing but root cos x. So therefore this and this are in the form this and this. So therefore f of x by f of x plus f of a plus b minus x dx. Directly we can say b minus a by 2. So the answer should be I is equals to b minus a by 2, that is pi by 2 minus 0 by 2, which is pi by 4. It's simple, right? So if any integral is in the form, you need not to solve this way, and you can directly apply this shortcut method. Yeah, thank you.